Good afternoon, everyone. Basically, my plan for today is to briefly go through the previous assignment question, just a repetition. For that, I skipped the week 11 and week 12 contents because those are quite recent. Basically, we'll just go through week 1 to week 10 selected questions so that it is useful for your upcoming exam. And I wish you all best luck for the exam. I hope I'm audible, right?
Yeah, thank you so much.
Thanks.
And thanks for conducting one extra session for all of us.
Oh, thanks.
I, I have two queries, very small.
Yes, yes, sure.
If you want, we can take up in the meantime the people are joining.
Sure.
Okay. Can you share my desktop?
Yeah, sure.
Visible?
Yes, it's visible.
So this is the PDF of the week 6, your session.
Okay.
Actually, here it is x plus 24 divided by 216 and it should be greater than 7 by 16. So if we divide this 216 by 16, it actually comes out to be 13.5, not 18. And if I multiply by 7, then it is 94.5 and minus 24, it will be 70.5. So now my question is, in this case, do we have to take it 71 onwards or 70 onwards, or we have to keep it 70.5 here instead of 102?
Okay, if it's 70 point, if it's coming out
Because it is coming in points. That's why I'm confused whether to apply floor or ceiling.
okay, it should be 71 as per my
It
understanding.
should be 71. Okay, okay. Got it.
Uh, by the way, thanks for like pointing out this error. I completely missed it.
So we have to take it 71.
Yes.
Okay. Now the next question is this one on the assignment number 11.
This one. Yes,
Hmm. This one I'm confused why this is invalid. Because 25 slots is between 4 and 640. This is okay. Slot offset is also okay for periodic. Then why this should be invalid? This is
actually when
because
I
if we get some insight, then it will be useful for the exam also.
Yes, because actually, when I went through the lecture, my initial understanding is that the period can be anywhere between. I think it's what is the like?
No, it has to be between 4 and 640. So it is 25 is between 4 and 640.
Yeah, but actually, one person pointed out in the group only. That's even though the lower and upper limits are okay, like 4 and 640, like in
Yes.
between they cannot take continuous value. Actually, some discrete values are only
And
allowed.
slot offset is also okay.
Yeah, slot offset is okay, but when it comes to that period, that 25 actually is not included.
No, actually, most of the people will be going as per the lecture because in the lecture it is
Ha,
mentioned 4 to 640,
true.
not as per 3GPP. I also saw that mail from one of the persons who I think Suhas Mandal has written that mail along with the 3GPP snapshots.
Yes. So,
Let me display that also. There also, I can just give me a second. I can come to that also. Actually, here also in I can see it is continuous only. Just give me a second. Question number three. Like this, not this one. The other one. It was yeah, this one. No. Yes, this one. Here it is talking about no 4, 5, 8, 10. So 25 is not there. But if we go as per this, see 0 to 3, then 0 to 4, 7. There I don't see any. Achha,
This is offset. This is offset.
okay, after
Left one is the
19 it is
periodicity.
31.
Right one is the offset. Hello.
Hello.
Yeah. Actually, left side one, na, that is the periodicity. Right one is the offset.
Yes, yes.
So offset will be always less than slot. So periodicity 25 is not allowed. 15 is allowed, 20 is allowed. So if you are keeping your slot periodicity as 20, then you have to keep your offset like 0 to 19
Got,
anywhere you
got it,
can
got
keep.
it, got it. So we should go
Because
as
there are
per
two
3GPP
parameters.
in the exam. Now the question is how the examination is prepared, whether as per the lecture or as per 3GPP. Otherwise, we will give the correct answer and it will be considered wrong.
Yeah, like it's like uh, I think it's
But we need clarity whether to take 4 to 640 in the exam or we have to go as per 3GPP. We will do whatever Swaraj will suggest.
I would say 3 GBP only. So
3GPP only,
uh,
not as per lecture.
yeah, because this is the point actually. Like there are few occasions, like this occasion
Okay,
I can remember, where it's not exactly matching.
got,
So it's better to go with like
got it.
3 GB version.
Okay. So for whatever written is in this mail, we will copy paste for our reference. So that we go as per that only.
Yeah,
Okay, got it. Thanks for the clarity.
sure, sure. So let us start with the first question of the day. It's pretty simple one. It's the basically the relation between the spectral efficiency, the rate, and the SNR. So we are said that capacity is 10 bps per hertz. So what should be the minimum SNR in terms of dB actually for this question? How I'm supposed to find that? We are given the capacity, that is another way of saying the rate, that is 10, and how is it related to SNR?
Log of 1 plus SNR.
Log of 1 plus SNR. And what is the base of the log? Base 2 or base 10 when I compute capacity?
This is best thing.
Log base 2, right? Okay. So in linear scale, what is the approximate value of SNR I'm getting here? Just I need the approximate, not the exact value, like in what order. It should be 1 plus SNR should be 2 to the power 10, right? That means in linear scale SNR value is 1023, which I can approximate as 10 to the power 3. Now can you please answer what is the SNR in dB going to be?
10 log 10 of SNR will be
Okay, 10 log 10 to the power 3, that comes out to be 30 dB, right? So it's the third one. What about the relation between subframe and slot for different subcarrier spacing? For example, here we are given subcarrier spacing of 120 kilohertz.
So 120 it is 8.
120 it is 8. For 120 kilohertz we have 8 slot per subframe. And what is the difference between subframe duration for a subcarrier spacing of 120 kilohertz and 15 kilohertz?
So 120 and
120,
60.
no, 120 kilohertz and 15 kilohertz. What is the difference in subframe duration?
15 is 1 millisecond, and this one would be mm, point one to
But suffering
point three.
duration will be same only, na? Slot duration will vary. The suffering duration will be same only. Want a different 10 minutes. One suffering will be 1 ms. So within 1 ms, that slot duration will vary.
So we can say that subframe duration is subcarrier agnostic. It doesn't really care whether we are having 15 kilohertz or 120 kilohertz. Subframe duration is always going to be 1 millisecond. It's a slot, that is, slot duration is going to be dependent over my subcarrier spacing. Fine. What about when it comes to this hybrid automatic repeat request? How many variations are there? One is mentioned here, that is incremental redundancy. What is the another one?
Yes, company.
Chase combining. So for this question, it concerned with incremental redundancy, where we have effective code rate of 3/4 and we made an initial transmission. Turns out the receiver failed to decode it in the first attempt and request for another one transmission. So what should be the code rate at which the receiver was successfully able to decode the data?
1 by 4.
Okay, let's first say if we calling 3/4 effective code rate, that means I can write it like this. If I have 4 bits, I am in first transmission, I am sending 3 message bit, 1 parity bit. Receiver fails, ask for a retransmission. So in the redundancy version, we are sending uh, 4 parity bits now. So if I combine both two, we have 3 message bits and 1 plus 4, 5 parity bits. So what is the effective code rate? 3 message bit, 5 parity bit. It cannot be 1/4, right? So if I am transmitting 3 message bit and 5 parity bit, what is my effective code rate? It's the number of message bit divided by number of total bits, and that comes out to be, we have 3 here,
3 by 8.
3/8. Now in case the second retransmission also fails and receiver asks for another one, that is the second retransmission, then we'll in that case we'll send again uh, 4 parity bits. In that scenario we will have 3 message bit and 4 plus 4 plus 1, 9 parity bits. In that scenario it will be 3/12 or 1/4, but since it's asked for only one retransmission, the code rate is 3/8. By the way, this is about incremental redundancy. Does code rate changes in chase combining also in the similar manner?
No.
Okay, so it remain unchanged, but for incremental redundancy it changes. Okay, so we are given following specifications. We have certain bandwidth given, subcarrier spacing, number of FFT points. We are supposed to calculate the CP length of first symbol if rest of the symbols have a CP length of 288 samples. So yeah, so how should I proceed to solve this? So the
So first we need to calculate the number of sub-carrier, no? How many sub-carrier will be? Okay, IFFT is given. No?
your I50 is given, so you have 4096. So in each symbol, oh, by the way, in each symbol, then how many uh, bits are going to be there? If I talk about in, let's talk about each symbol, or let me correct it. Bits per symbol. How many? 4096.50 you are doing, so it should be 4096. Should something need to be added or subtracted on top of that? We have additional sorry, I should not mention here bits, it should be samples. So 4096 is the number of information bit, and on top of that we have given the CP length of 288 samples. So it is going to be 4384 samples per OFDM symbol we have. And what is the sampling rate, by the way? How do I, if I plan to calculate the sampling rate, what it is going to be?
4096 into 15 divided by 1000.
So it's basically n over t, that means n times del f, that is 4096 times 15 into 10 to the power 3, or let me just calculate once.
Yeah, I think it will be divided by 10 to the power 3.
uh, but it's 15 kilohertz, right? So it's 15 into 10 to the
Yes.
power 3
Yes.
only. It's n over t.
Okay.
uh, t is the duration between these WebDM symbols, and that times n, so it's essentially n times del f. So let me just calculate it. 4096 times 15, 61440 into 10 to the power 3 sample per second. So since our subcarrier spacing is given as 15 kilohertz, we remember that subframe and slot duration are same. So slot duration is also 1 millisecond in this case. Slot duration is 1 millisecond. So that means here we have see this is sampling rate. So therefore sample per slot is going to be just 61440. And by the way, how many symbols in one slot?
15 symbol.
14. And how many samples we are having here on by adding CP? 4384, right? So 14 times 4384, and that should be 4384 times 14. 61376
Mm, 76.
samples. So in a slot, according to the sampling rate, I am supposed to have 61,440 samples, but from this calculation I am getting 61,376. So what is the difference? 54 samples. And where does it go? Like
Excellent.
conventionally that goes to the first symbol. Like the CP length is basically added up. So it's like for first symbol only, the CP length is first symbol CP length 288 plus 54. That is okay. It's 64. Sorry, it's not 54. That means we have 352 sample CP length for first symbol only. So we are given a transport block of size 16 bit. We have a generator polynomial. How am I supposed to get the CRC? Okay, like what is the, if we are given like this, d to the power 4 d3 and 1,
It will be 11001.
11001. Okay, so I have these two sequences. How to use them?
We need to add 4
In
zero at the
16
end.
bit, we have
So I need to divide 1101 0 triple one 0010 1110 and 11001.
we we have to append 4 zeros also.
Sir, we need to add some zeros. No?
Okay, so you need to append four zeros. Fine. And how I'm getting the CRC as a quotient, or what is the remainder? So let's try.
Remember, remember.
So it's 11001. So first three out of picture. Here I have 1 1. I'm basically ignoring the zeros here, not writing them because they don't make much sense, because we are not interested the sequence here. So 11001 100. So we are basically left with 1000, and that is going to be my CRC.
CRC.
Is that okay, or I did something wrong here?
No, it is okay.
Okay. So this is regarding the concept of LDPC encoding decoding. Here we are concerned with base graph 1. We are given a particular block size, and of course a lifting size table is given. So we are supposed to find the code block size for the transport block. So so first of all, how many code blocks are going to be there, because we are given the transport block size, that is one. Just a minute. Yeah.
14010 plus 24 divided by 8448 plus 24.
Minus 24.
So it should be 14010 plus 24 divided by 14010 minus 24, and ceiling of that
Then divided by 8448 minus
For
24.
8448, no? Per code block maximum size is 8448.
8448, and ceiling of that. So we are getting 2 here. So what should be my next operation? So I have 14010 side transport block. So we have a transport block CRC size of 24. On top of that, I have to append code block CRC. There are two code blocks,
Yeah.
and
Plus
again,
2 into 24.
so it's 14082. Fine. It's what next should I do?
For into 3 gram jersey value, so the 22 into jersey will be greater than this one.
So
So,
I'll divide it. Okay, divide by 2. 7041. Fine. I got a number. Now is that the code block size, or
no, we need to set it as per this jersey value. So, 22 jersey to like to pick on jersey, so the 22 jersey will be greater than this one. 7041 and the rest of the bit will be similar.
okay? So 22 times ZC should be my code block size that is feed to LDPC encoder, and that of course need to be greater than 7041. You are saying any residual bits should go as filler bit. So what is the value of ZC we are expecting from this table? First of all, let me check what the ZC value going to be. 7041 divided by 22. It should be greater than 320. So the number greater than 320 are
So
320.
320 is there, no?
There in the 320 is also there in the table.
Yeah, 320 is also there, but the number comes out to be greater than 320, like
I
ZC.
know it is greater than equal to 22 ZC should be greater than equal to 7041. So it will be 320 only. So filler bits will be 0.
But like ZC need to be what is that? Um, a integer, right?
Yeah. No, I think we are doing correctly. It will be 320 and then number of filler bits will be 0.
Okay, so what I'm saying, as a if I try to compute ZC value from here, it comes out to be 320.045. So it should be greater than equal
Okay.
to 320.
320 is less, so we cannot take 320. It will be 7040, no? We have to take more than that.
So 320 is out of picture because ZC need to be an integer.
Yes, yes. Then it will be 352.
This to our only option, and the closest option is 352.
Yes, yes, yes.
So for me, ZC is 352.
352.
So the code block size is 22 times 352. That is
352.
7744.
44.
So lifting size we already has
352. Filler bits 3.
352 filler bits 7744 minus 7041, that is 703, and
Yes.
LDPC encoder
Output.
output length.
It is coming to be 23232.
So that is code rate of
66 ZC.
code rate of one third. So it's 66
ZC.
ZC. That is coming out to be two. Uh,
23232.
thanks. 23232. Now, if this is modified to base graph 2, and we are asked to find the encoder output length, can we just alter the mother code rate as from one third to one fifth and calculate, or something needs to be done?
Because 50 gets you for put regular put.
Okay, so it should start from here. It should be 50 ZC first of all, and here it should be.
No, not here. In the next 50 bits. Next 50 bits.
Oh, you are saying here.
Yes.
Okay, but the thing is, like, whenever we are mentioned base graph 2, uh, your this number
The
also
table
change,
also gets changed, no? Right, right, right.
and also this number will also change. It The maximum length is not 8448. I guess it's I don't exactly remember. It's 3552, right? For base graph 2, or but something in the 35, like 3.5k range. So we just cannot change the answer here. The calculation from the very beginning will change, because the maximum number of bits per code block changes. So your code block number, and then the lifting table, of course, changes a bit. Here it is not 22 ZC, it's 10 ZC, and of course the mother code rate being one fifth, it's 50 ZC, but things starts changing from here itself. So entire calculation need to be redone. So about this question, we are given a bit sequence. uh, it comes to interleaving, that means after the rate matching block, as the output of rate matching block, we are getting this bit sequence. Now we have to perform interleaving, and the modulation scheme is QPSK. So what should be my interleaved sequence? How am I supposed to get it?
So for PPSK, we need to divide it in two rows, and then we'll be interleaving in row and column.
Okay, it should be first of all QPSK, so it should be two rows. And how should I read them? Like, for example, the first element goes here. Where does the second element go?
No, no, no. First we need to divide it in two bits, no? Half. So total how many bits are there? 1, 2, 3. 12 bits are there. So first 6 will be one row, second 6 will be one row. Then we'll be doing it in one row, one column, one row, one column.
Okay, so you are saying I should read the, okay, like this: 1 0 0 1
Right.
0 1 0 1 1 1 1 0. Okay, and then how am I supposed to read it?
No, no, sir, I think first bit we need to write in first row, and second 8 bit we need to write in the second row. Then will be going in column wise. First 8 bit. Sorry, 6 bit.
Okay, so you're saying first 6 bit I should write in first row. Fine.
That is one row. Yeah,
Okay, and the second last 6 bits goes in the second row. Fine. 0 1
yes.
1 1 1 0, and then
Now 1 0 0 1 0 1. Now we'll read column wise.
so I
This
should
is one
write
column, then next column. Ah, right, right.
okay 1 0 0 1 0 1 1 1 0 1 1 0. Thank you. So this is our transceiver chain. We have gone through multiple times. What is the correct order for the processing of PDSCH channel?
First one only.
So first to do segmentation, go for LDPC coding, rate match and interleaving. First one. So now we are allocated 150 PRBs over 14 symbol. We are given some transport block size 32984, 64 QA modulation. We are supposed to calculate the circular buffer length for each code block, and again it's base graph 1. And so if I talk about circular buffer length, what does this number exactly represent? This circular buffer is input to the rate matching block, right?
Yes.
That means it's the output of LDPC encoder. And what is the LDPC encoder output length for base graph 1? We have just seen in terms of lifting size. It's 66 ZC, right? So just we need to find the correct ZC for this case. So we have 32984 plus 24 divided by 8448 minus 24, ceiling operation, this many code blocks. And there are four such code blocks. That means 3 2 9, sorry, 32984 plus one transport
24.
block or four code block CRC, to total 5. 5 into 24, that is I have 32
Yeah,
984.
one more 24 will also be added. 3 to 984 plus 24 plus 5 into 24.
There is one transport block CRC and four code block CRC, so in total 5, right? Am I
Okay, got it.
so 120 here? So we have 33 104 bits, and if I plan to divide it, by 4, I'm getting 8276. So 22ZC again greater than 8276. You can see this number is actually very close to this 8448, so there cannot be anything in between, so my ZC is going to be
384.
384 in this case. And the circular buffer length, since uh, 384 into
25344.
25344. Thanks. So now I have to calculate the effective code rate for this scenario. Effective code rate. So this should be number of information bits per code block, and resource allocated per code block. So which one of this number we already have? If I talk about number of information bit per code block, which one is that? It is 8276, right? Because the rest of them are filler bits only if I talk about a single code block.
Yes.
So here it should be 8276. And now the task is to find the number of resource allocated per code block. So for this will come into picture. 150 PRBs over 14 OFDM symbols, and what it should multiply with 64 QAM modulation. So how many bits per sample?
6.
6 here. Anything else I should multiply with? The number of resource element per PRB, right?
Into
That is
12 subcarrier.
that is 12.
Into 12.
So this is the
Sir,
whole.
here DMRS overhead will not be taken care.
Yeah, that's true, but uh, 3 should be reserved for DMRS, but
Into 9.
so it should be let me just calculate it.
1314
Sir,
double.
one question. If we will multiply here 9, then we are calculating is like DMRS is going in uh, three symbols for all the subcarriers, right?
Yeah,
And
but
that is 14 symbols.
yes, like per symbol we are reserving 3 subcarriers for DMRS.
But that is not correct, no?
Yeah, there is
Because
another
DMRS
thing.
we are only right.
You are reserving 6 subcarriers over the entire slot, like over 14 symbols. That's what you are referring to, right? Like if I talk about 14 symbol, 12 subcarrier, that is 168 REs, among which only 6 are reserved for DMRS. So 162
Right,
is for
right,
that one you are referring to.
right.
So actually in different part of different session I have encountered both. So I'm also a bit confused that which one should I go for.
So normally we should multiply here 158 into 162, right? We'll be going through that concept.
Yeah, like so you are talking about this one. Just
Yes.
is this one you are referring to?
Yeah.
Okay, let's as of now use this only, and I'll just ask the course TS once about which one to go for if nothing is mentioned, uh, and then update it in the PDF file upload in the drive. This question part, so that for exam there is no confusion if there is nothing mentioned. So it's 150 times 6 times 162, that is 145800. Now if I talk about at each code block, that is 36 450. So this should be my effective code rate, right?
Yes.
8276 divided by 36 450, that is 0.227. So we are given a AWGN channel wise x plus noise. We are also given the distribution of noise here, and we are supposed to calculate the map threshold if the transmitter is transmitting BPSK symbol such that 0 is mapped to -1 and 1 is mapped to 1 with some probabilities. So let us first visualize the noise part, like the PDF of noise. So between 0 and 2 its slope is negative, and its value comes to 0 at 2, so it is like this. And for negative region its slope is positive, so this is -2 to 2, and its maximum height is here 1 over 2. If we calculate the area, it comes out to be its 1, because the area under PDF is always 1. Now we are supposed to find the map threshold. By the way, what does this map represents? Map stands for maximum
A posteriori probability.
a posteriori probability. Okay, and these two probabilities we are given, are these having specific names? See, y is the thing we are observing, x is something that is being transmitted, and noise is something that is corrupting what is being transmitted. So when I say the probability of x being 0 or x being 1, it has nothing to do with our observation. So it's like it connects to something even before the event y happened. So these are called, can you remember the name? These are prior probabilities. It has nothing much to do with the observation and the this experiment itself. It is the prior probabilities of x being transmitted, whether it's for 0 or 1. So if we apply the Bayes rule, it turns out okay, so maximum a posteriori probability is written in terms of this p of x given y. By the way, why it's called a posteriori, like in what sense? Basically a posteriori means something like after the event has happened. For example, we have seen y, like we have observed y. Now based on y we are trying to predict what x is being transmitted. So that's why a posteriori probability is written as in this form, p of x conditioned on y. Condition mean we have seen y, now given y, what is the probability of x being transmitted? And it turns out from Bayes rule we can see it is proportional to px times p of y given x. Px we have already encountered, this is the prior probability, this is the a posteriori, and this one here is the opposite to a posteriori, it's the likelihood. Here we are conditioned on x, like we are assuming that some x is transmitted, and then we are trying to see the probability of y being received, so that is what we call likelihood. So basically if we need to find the maximum a posteriori probability, we need to maximize the product of prior and likelihood. And basically how do we find the likelihood? So if you see that probability of noise is given, and y is x plus n. Now if it only unknown part for us is likelihood now, because the prior is already given to us, likelihood is something we need to calculate. Now whenever I say that it's conditioned on x, or like probability of y given x, that means x is kind of deterministic. And when x become deterministic, what is the distribution of y? We are given the distribution of noise, x is some constant, so how is y going to be distributed? Any idea, like intuition? We are given distribution of n, we are told for likelihood x is constant, so x is basically some number which is fixed. So what is the distribution of y going to be? The distribution of y going to be same as the distribution of n, just shifted by the value of x. For example, when x is 0, we are transmitting a like a PPSK symbol, that is 0 is mapped to -1. So basically let's call it x1 being transmitted. Okay, let's so for 0, -1 is just okay, yeah. So for 0, -1 is being transmitted, so y in that case is going to be p of y given x minus 1 is the same as this PDF shifted with its mean as -1. So if I try to draw the PDF of this, it's going to be something of this sort, like the entire thing is shifted its mean to -1, so something of like this, -3 1 and mean shifted to minus 1. Similarly, p of y given x as 1 is the same PDF as n, but its mean now shifted to 1. So it's now between 3 and minus 1. And basically, what is the like condition of this map threshold value? So the idea is that if p of x being minus 1 given y is greater than p of x given 1 being 1 given y, then your decision is going to be in favor of x minus 1, otherwise you will decide x is 1. So basically what we need to calculate here is whether p of x minus 1, that is the prior, this one is likelihood greater than p of x 1 p of y given x1. Basically, when this probability is greater than this, you are going to decide in favor of minus 1, otherwise 1. So if I am trying to find some threshold, basically I am looking at the point where this probability is equal. That is where I am supposed to find the threshold. And by the way, the expression of this one, how do you find it? So if you look at this expression here, what you do is it's the minus, let's say it's a variable called alpha, minus, for this one it's minus uh, alpha minus 1 over 4 plus 1 over 2 for uh, it's between 0 to 2. Now it's between minus 1 alpha and 1. Okay, let me just, it's getting too cluttered, so we are drawing the likelihood of this x being minus 1. We find its PDF as mean being shifted to minus 1. This is minus 3, this is 1. So what is the uh, expression for this one is minus alpha minus 1 divided by 4 plus 1 over 2 for alpha varies between minus 1 to 1, and it's alpha minus 1 by 4 minus 1 over 2 for minus 3 alpha minus 1. Similarly, for p of y given x as 1, it's the one shifted to mean 1, and this expression is given as alpha plus 1 by 4 plus half in the range 1 and 3, and it's alpha minus 1 minus 4 minus half in the range minus 1 alpha 1. So if I try to plot both of these at the same page, like somewhere here, maybe something of this sort, so you can see that this side of this probability is going to interfere with this side of this probability. So and what is the expression of this line here? That is -1 to 1, this, and this line here is this. But remember, they should be multiplied with prior probabilities also. So what is the prior probability of x being -1 when you are when your 0 is mapped to 1? That is 2 over 3, right? So you have 2 over 3 times this expression, minus alpha minus 1 by 4 plus half is equal to probability of x as 1 is 1/3 the prior, and what is the expression of this side here? Alpha minus 1 over 4, alpha minus 1 over 4 minus 1 over 2. So what we are getting here, if we take this that side, 3 alpha 1 minus, sorry, alpha minus 1 over 4, right, taking this that side, and 3 by 2 here, we'll have 1, and here I'll have 3 over 2. Yes, so the alpha is coming out to be 3. Okay, I guess I did something wrong, so let me check once. Okay, sorry, it should be both plus here, so it should be also plus. It's 1 over 2. That means your here it would be 1 plus 2 over 3. Sorry, this should be alpha plus 1 here. Let me just redo it. So let's just bring the only alpha terms there. So we have alpha by 4 here. Here I have minus alpha over 2. So on this side when it gets, it's 3 alpha by 4. And on that side what remains is have 1 over 4, 1 over 2 plus 1, that is 3 over 2 minus 1 over 2 minus 1 over 4. So it's 3 alpha over 4 as 3 over 4. So alpha comes out to be 1. Let me just check once if things are correct.
For me also it is coming out to be 1, not matching with any of the options.
1 only, right? So okay, so the
Yes, not
options.
matching with any of the options.
Okay, so basically all are incorrect according to. I'll just check once also, but as of now, okay. So as of now, let us consider the answer to be 1 only for threshold. So we are given 110 PRBs that is allocated across 10 OFDM symbols, and we are given the modulation scheme, also the code rate. So what is the number of intermediate information bits available to the user across two layers, and we have to give n info over 100 as the final answer. So if we talk about the number of REs uh, in one symbol, sorry, not one symbol, in one PRP across 10 symbol. So we are getting 10 into 12, and 6 we are subtracting anyway, so it's 114. And so n info is going to be 110 such PRBs, 114
into 8 for 256 square
256 square
into 700 to 1000. Yes.
1000. So if we are supposed to find n info over 100, it's 100 into 144 into 8 into 7 divided by 100. 11 times 114 into 8 into 7. So it's 702.24. What about this one here? We have received RF signal, that is in phase and quadrature component, and our local oscillator has some phase offset, so that when you decode the baseband signal after low pass filtering, you are left with this what should I say, like residual phase shift. So if your phase offset is given as phi, then what is the value of phi? How am I supposed to find it? So first of all, this RT, what do we exactly do with this? Like we have this local oscillator thing, we have RT that comes into picture. So what is being multiplied with respect to local oscillator? Cos omega naught t plus phi, and here it's sine omega naught t plus phi. This is what we are getting as R bar t. So what should I do here? I should multiply RT with cos omega naught t plus phi. RT cos omega naught t plus phi. By the way, there is a sorry, low pass filter involved here. Forgot to introduce it. So we are only concerned with the baseband component. So if I multiply RT with cos omega naught t plus phi, what we are getting here? Root 2 I cos omega naught t cos omega naught t plus phi minus root 2 qt sin omega naught t cos omega naught t plus phi. I am ignoring the noise part because it's anyway it doesn't really carry information. So here I am supposed to get 1 2 omega naught t plus phi kind of component and another component only containing phi. So we are not cared about 2 omega naught thing because we are passing it through low pass filter. So essentially at the output, sorry, here we are not getting 2 omega naught thing. So what we are getting here from cos omega naught t times cos omega naught t plus phi. If you talk about the baseband part, it's cos a plus b plus cos a minus b, right? So essentially we have cos phi here. Similarly here we have sin a cos b. So what is the formula for that? Sin a cos b it's sin a plus b plus sin a minus b. Is that correct, or I'm doing something wrong here? Here I have minus root 2 qt sin of minus phi. This is about the things that comes here. What about here? It's rt times sin omega naught t plus phi. That makes it root over 2 I t cos omega naught t sin omega naught t plus phi minus square root of 2 qt sin omega naught t sin omega naught t plus phi. What is the baseband component I am getting from there? For here I have root 2 I t sin phi sin a cos b, and from here it's sin a sin b. Sin a sin b is cos a minus b minus cos a plus b. So cos a minus b is our concern, so we can square root of qt cos phi. So this one sine of minus phi and minus here, so I can consider it as a plus phi, and this one is getting multiplied with 1j here. So ignoring the root 2 part, I can write it cos phi plus qt sin phi plus j it sin phi minus j qt cos phi. So if I plan to write it as follows, it plus j qt think sin a cos b just let me check the sin a cos b thing once. It's true, only sin a plus b and sin a minus b, so in that sense it should be okay, qt sin theta only. And here I have cos and sin a minus b. Local oscillator pf sin a sin b. Just let me calculate here the baseband signal once. So RF signal is real part of baseband signal times e to the power j omega t. This one here is I plus jq. So real part of I plus jq times cos omega t plus j sin omega t. It's I cos omega t minus q sin omega t only. I should be able to write it in this form. This is my baseband signal st, and it should be st times cos phi plus j sin phi, essentially st times e to the power j phi, but the equation is not matching. What is going wrong here? If I multiply this with minus 1j, in that case it would be minus here and it would be plus. In that scenario, if I try to write it, it should be it should be sign of minus phi here. So this become minus jit sin phi, and it's jqt sin phi minus j square minus 1, another minus 1 here, cancel out. So qt sin phi, and we can write cos of minus phi because cos of minus phi and cos of phi are same only. So I should multiply here with minus 1j. Minus 1j. In that case it would be cos of st times cos of minus phi plus j of sin of minus phi. Then it would become e to the power j minus phi. If we compare this term here, e to the power j minus phi, e to the power minus j phi, with the expression here, that is 1 over 2 minus j root over 3 over 2, we can find that phi value as minus phi as minus 60 or phi as 60. So 60 should be the answer here. For this question here, we are supposed to compute the length of transmit DCI sequence. So what is the how many bits are required to identify the DCI format? Can anyone point it out? It's either uplink assignment or downlink scheduling. Sorry, uplink grunt or downlink scheduling, right? So it's between the choice of two that we can resolve using only one bit. Same applies for new data indicator. It's also one bit. HRQ process number. Turns out there are 16 such process ID, so you need log base 216, that is 4 bits. PUCCH resource indicator, there are 8 such possible combinations, so you need 3 bits. Redundancy version, we have seen RV0, RV1, RV2, RV3, 4 such, so there we need 2 bits there. And modulation and coding scheme, we see how many such possible, 31, right? So closest power of 2 is 2 to the power 5, 32, so we need 5 bits for that. So if we sum them up, 2 here, 4 6, 3 9, 11 5, we need 16 bits in total. So how about the finding the correct statement about polar encoding for downlink control information? Can the mother code rate length greater than 512 when it comes to polar encoding on DCI?
It should be less than 540.
It should be less than, so this is a false information. How about the code rate? Can it go even below 1 over 8? For polar encoder, the mother code rate is 1 over 8 only, so it cannot go any further. So this is a wrong statement also. And what about the third one? The length of the DCI, the mother code rate length should be greater than length of DCI.
This is correct.
This is correct. So we are given a CRC bit sequence. It's a 24-bit sequence, and we are given the RNTI value also for a particular user. So I have to find the scrambled CRC bits. So how to do that exactly? 24-bit CRC. So how many bits are there in the sequence for RNTI? Irrespective of the RNTI number, it's 16-bit RNTI, right? And how do I find the scrambled CRC bit? You have to perform the XOR operation. So we ignore the first 4, first 8, because it's 16-bit RNTI. So first 8 is ignored. The rest we pick 1 0 0 1 0 1 0 1 1 1 0 0 0 1 0 1. What about the number 5 1 3 7? If we break it down, we will see there are four numbers: 4096 involved, 1024 involved, and 4096 plus 1024 plus 16 plus 1. So this is the zeroth position, this is the fourth position, this is the 10th position, and this one is the 12th position. So if I create the 16 bit here, 15th bit is 0, 14th 0, 13th 0, 12th bit is 1, 11th again 0, 10th bit is 1, 9 0, 8 0, 7 0, 6 0, 5 0, 4th is again 1, third 0, second 0, first 0, 0th bit is again 1. If I perform the XOR operation, we will have 0 0 here, 1 0 1 0 1 1 1 0 0 0 0. And here I have to just copy paste the most significant 8 bit 1100 and 1010, and this is the total scrambled 24 bit DCI sequence for uh, but that particular user. So we are supposed to find the invalid resource allocation configuration for PDCCH control channel. So which one of this correct, by the way? How to find that? So we have seen for PDCCH transmission in the downlink, the core set has certain size, like only they can be transmitted at different aggregation levels, and that's being said there are only discrete number of uh, bits that can be transmitted. And what are those numbers? Can you just remind, like, what is the minimum number?
108.
108. So we have 1 CC, 1 CC, they have 6 RDGs, and 1 RDG means 12 subcarrier, 12 subcarrier, 3 is reserved for DMRS, so 9 is available, 6 such um, PRBs, RDGs mean PRBs. So it's in total 54, and the modulation scheme used is QPSK, so you can transmit 2 bits at a time. So it's 108 starts from, fine. And other possible numbers, it is aggregation level 1,
216
216,
432
432,
864
64,
and 1728.
728. So it's aggregation level 1, 2 here, 4 here, 8 here, and 16 here.
16.
And so if here they talk about PRBs here, so if we try to divide it, basically number of bits we can assign in one PRB, that is 18, right? 9 subcarrier available, 9 times 2 bits, 18. So if we talk about PRBs across symbols, what are the possible PRBs? That is 6 here, 12 here, 24, 48,
48 and 90,
and
48 and
96.
96.
So here it's 13 PRBs across two symbol, that is 26. That doesn't fit here, it's out of picture. 9
All
PRBs,
four are invalid.
so this is also invalid. So does this. So all of these are invalid. What about the valid aggregation level configuration here? If we are code set 32 cc's per FDM symbol across two FDM symbol, allocated symbols are 4th and 6th one, and period is 10 slot, and subcarrier spacing is 30 kilohertz. So if we talk about aggregation level, there are 2, 4, 8, 16 all are involved. So let's talk about aggregation level 2. How many attempts needed to cover all of them?
It will be 32
At one symbol it's
into 2,
32, aggregation level
divided by
2,
2
and it's
into 2.
spread across two symbols, so 32 attempts at aggregation level 2. What about aggregation level 4? 32 divided by 4 into 2, 16 attempts.
16 attempts.
Aggregation level 8,
32 by 8.
8 attempts.
8.
And aggregation level 16, 4 attempts.
32 by 16 into 2.
So you have 4
4.
attempts. So the first combination here, 8 and 16, that means all total 12 attempts. Is that valid? So this here is 12 attempts. So first write them. 248. 248 means 32 plus 16 plus 8. That is 56 attempts.
Yes.
56 attempts. What about 4, 8 and 16? 28 attempts. 28 attempts. And 16 alone is only 4 attempts. So by the way, the subcarrier spacing is given as 30 kilohertz. How many attempts are possible?
20.
30 kilohertz, it's
No, 20
36, right?
36, yes.
It's 36. So
36.
clearly 56 is out of picture. But 12, 28, 4 are
28.
all within range. So it's 1, 3 and 4. So here the user is assigned 6 PRBs across two FDM symbol to receive a PDCCH signal. We are supposed to find the DCI length for which puncturing will happen. So 6 PRBs across two symbol. So how many resource bits? 6 PRB, 2 symbol, 9 subcarrier per 9 resource element per PRB, and modulation scheme 2. So total 216. So by the way, for puncturing to happen, what is the condition?
Nmax should be 5.2.
Like for puncturing to happen, actually there is some restriction on the code rate. So when code rate is less than 7 over 6, we can go for puncturing. If it is greater than 7 over 16, sorry, and if it's greater than 7 over 16, we go for shortening.
Yes.
So for let's assume the unknown DCI length to be x. So essentially x plus 24 divided by 216 is my code rate, and that should be less than 7 over 16. It should be x plus 24 than equal to 7 into 216 divided by 16. So let us try to convert into integer. 7 into 216 divided by 16, 94.5, or x should be less than 70.5. And we know that minimum DCI length is, what is the minimum DCI length?
12.
12. And we have to convert it to integer. For example, since it's less than, we need to go for ceiling. So for DCI length between 12 and 70, for which can puncturing will happen. So here again is 6 PRBs across two symbols. So we know how many bits are there. Basically resource element to
I,
transmit.
I have a confusion on the previous question.
Yes, yes.
Actually, last time when we calculated, so then we had taken 102 to 140. We didn't start from 12, we had gone to the extreme of 140, the maximum, and earlier we calculated wrongly at 102 instead of 70.5, but we took the range from 102 to 140, the upper side. Now we are starting from 12 and taking up to 70.
Yeah, because that was a shortening. Like shortening is the code
Okay,
bit is
okay,
greater than 7/16. So in that case, it
okay,
ideally should be, as you mentioned, it should be more than
okay,
70.
got it.
Yeah, 71 to
Yes.
140.
So lower range will be puncturing, above one will be shortening.
Yeah, upper one would be
Okay,
for short. Yes.
got it.
So the resource bits available for transmission here you have already seen, that is 216, and our DCI length is 42. So how do I calculate the length of polar encoder here? DCI plus 24 bit CRC will be appended. So we know that minimum is 2 to the power 5, the polar encoder output, and it's less than 2 to the power 9. So it should be between 5 and 9. So the formula is something of this sort: n1 comma n2 comma 9, and it should be max with 5. Here n1 we obtained by taking this, like log base 2 resource bit e here, and uh, actually whatever number we get here, that should be okay. This, there should be floor operation, sorry, ceiling operation. So it should be uh, 8 here, and n2 is the with the mother code rate, that is this is the information bit plus CRC, that is 42 plus 24, that is 66, and the mother code rate is 1 over 8. So n2 is log base 2 8 into 42 plus 24.
22 plus 24.
So that should come out to be 8 for 8. Let me just calculate once. 66 times 8, more than 528, that means it crosses 512, that is a 10 here. So essentially it should be max min 8 10 9 5. So it's here, it should be 8 and it should be 5, so 8 here. So polar encoder length n should be 2 to the power 8 or 256. So none of the options are correct here. So you have to calculate the number of null bits in channel interleaving during PUCCH format 2 transmission. So allocation of 10 PRBs over one WebDM symbol with a reference signal overhead of 1 over 2. So by the way, when I say that reference signal overhead of 1 over 2 or 0.5, that means if there is a 12 subcarrier, half is occupied for reference signal. That means essentially 12 minus 12 divided by 2 is what is available for each PRB at each symbol. Now we have 10 such PRBs, and of course the modulation order is 2.
Into 2 for QPSK.
So we have here 120 bits. We have seen that PUCC how it should be arranged when it comes to interleaving in this format. Essentially it should be T times it's a triangle of height and base T, so it should be T times T plus 1 over 2 should be greater than E, or T times T plus 1 greater than 2E. So essentially
So
the number of
15 into 16 comes out to 50.
okay, so then the null bits which should be T times
Then
T plus 1 over 2 minus E. In that case it's coming out to be exactly same the meaning of
yes.
T value, so number of null bits should be 0 here. So this code set 0 is being transmitted during the initial access, right? So what are the correct statements for code set 0? Is it configured by the master information block? Actually code set 0 is indeed configured by master
All
information, and user should use system information RNTI, because code set 0 doesn't have any user specific RNTI. That is also correct, since
it.
it's PDSCH transmission DCI format
Third one
1010.
was
And what about the fourth one?
assumes continuous mapping. So it assumes interleaved mapping, not continuous mapping.
Yeah, for code set 0, since the channel information is not known, it's safer to go for interleaved mapping, because base station do not really have idea whether the user channel is good or bad over what frequency, so it cannot go for continuous. Okay, like for example this option is okay, or the answer is going to be wrong, should be interleaved. So user having 8 antennas and G node B having 12 antenna. So if a user need to estimate the unprecoded channel, how many CSI RS ports G node B should configure? When it comes to estimating the unprecoded channel and CSI RS, is that something depending on the transmit antenna or receive antenna?
Transmit antenna NT
Transmit antenna.
12.
So we need 12 CSI RS ports. What about the following statements, the incorrect ones we are supposed to find? So can G node B cannot use SRS to estimate the unprecoded channel, is that false?
It can use, so it is false.
So it is false. What about G node B using DMRS to find the precoder matrix?
It uses CSIRS, not DMRS. So this is also false.
The third one.
This is false.
But in a MIMO system, user only uh, care about the effective channel at its side, right? I mean, when base station does the pre-coding, user received something low dimensional, and it is only thing they care for. For example, if channel is H and base station is transmitting, like using precoder V to transmit X, so at user end user is seeing H V
Encoded
X,
channel.
so it should be like H tilde X, and all user care about this channel. It doesn't care
Yes.
about individual H and V's. So usually in
Yes.
MIMO user demod. So this is false. I mean, this is not false.
So
So essentially it is wrong.
the, the statement is true, yes.
Yes. And about the rank of matrix being less than, can it be possible?
It can be less. No,
Yes.
actually, it is written can never be less. So this is a false statement.
This is false statement. So this is correct. What about this 3 cross 3 uh, channel? It's not 3 cross 3 channel exactly. It's a diagonal matrix comes out to be 3 cross 3. So how about if this is the structure of SVD? What is the number of layers that can be transmitted over the channel?
Mm. Only one.
So you are allowed to only transmit one layer here. So we are talking about DMRS of type A, and we are willing to transmit three additional symbol. So what is the minimum number of FDM symbol that should be scheduled to even uh, allow myself to transmit three additional single symbol DMRS of type A?
Three additional type A. Is it 12?
Yes, so it's at least we need to schedule the data over to 12 OFDM symbols to even allow transmit three additional single symbol DMRS. So what about this one? Number of R is available to transmit the PDSCH data bits. So number of PRB allocated is first of all we uh, see how many in total bits are like allowed, including DMRS. So 150 times
8 into 12.
8 into 12, and that means 144, right? Now for DMRS, we have one additional DMRS on top of the original one. That means 2 here. And number of CDM groups without data, that is also given as 2. Sorry, this is not bits, this is REs. So here we have so type A, type 1 mean this they are occupying 6 subcarriers in per RE, right? If I'm um, yeah. So like per PRB, uh, they are occupying uh, 6 alternate every alternate subcarrier. So that means essentially 3600 REs. So for downlink data transmission, only available bits are only 10,800 REs are available. 150 PRBs, okay. Type A, type 1, so alternate. In each PRB there is 6. There are 2 symbols and 2 CDM groups, okay, fine. What about the number of hops here, the hopping cycle? Okay, the information might be missing here, so let me give here. For CSRS 15, N1 is 2, N2 is 7. So number of hops, how do we calculate? B as B hop plus 1 up to BSRS NB. So here B hop is given as 0, BSRS as 2. That means it runs from 1 to 2. B runs from 1 to 2, NB. So it's N1 times N2, that is 14. So for CISRS 31 here, let me introduce the additional information. MSRS 0 is, let's say it was 128. MSRS 1 is 64 and MSRS 2 is 16. Now what is the SRS power density is going to be compared to when you compare BSRS 2 and BSRS 1? So at here at each hop I'm kindly sounding 64 and here I'm sounding only 16. So what is the increase in density? Let's see, if we talk about subcarriers, if we are sounding 64 subcarriers at a time, like at a symbol, and now I'm using the same amount of power to sound only 16 subcarriers, what is the increase in SRS power density? SRS power density, it's 10 log base 10 4, right? Because I am sounding 4 times less bandwidth. So essentially my power is more concentrated. It's 4 times comparatively concentrated compared to BSRS1 in BSRS2, and that is 6 dB improvement. So here we have this SRS sequence. We know SRS sequence are created from Zarovchu sequence, and we also know that Zarovchu sequence are the underlying base sequence is of length of a prime number, because in that way you can generate maximum number of orthogonal sequence. So what is the value of nzc for this case? Okay, for this information is needed, so let me give you that also. M SRS1 is 44. So comb spacing is 2, so that means every alternate subcarrier in PRB you are sounding how many PRBs? 44. So total sequence length should be 44 times 12 over 2. 2 because comb spacing is only 2. That turns out to be 264. But that is the number because it's increases in granularity of 4 for SRS sequence. But the underlying Zarovchu sequence is the closest prime number, right? Closest prime number less than 264, and that is 263. So your length of Zarovchu sequence is 263. Basically you just generate a 263 length Zarovchu sequence and repeat one bit just to make it length 264. So this is pretty much all for today's session. There are confusion in 1-2 questions. I will just recheck them and update them in the uh, final PDF that I will upload in the drive, and I'd be happy to answer any questions regarding the content of today's. Regarding the exams, I really don't have.
Sir,
Yeah.
where we can get this PDF?
Uh, Sorry. Can you just
From where
repeat?
we can get this PDF?
Oh, it's in the where you are shared with that Excel sheet kind of thing, right? Where the YouTube link is also
Yeah,
given.
their recordings are available, no?
Yes, like recordings are available also, and the PDF, there is a drive link, na? Okay, just let me share that. Let me open so that. Um, so you can access this sheet, right? Where you can find the links and all that.
Yes, yes.
So in the presentation folder link, if you go there, if you go in this folder, you'll actually have access to all the PDFs of, like, and here I'll upload this session also. Of course, the recording will be available, and so
Okay,
does the
okay, okay,
PDF
okay.
also.
Yes, okay.
Okay.
Okay. Sir, one question like in that tables will be available in exam or we need to buy out all these tables?
Like for example, this
Like
thing.
that question like what is the like in the beginning of the lecture we have discussed regarding that CSIRS resource periodicity, right? So there are 16 or 17 values which are allowed, but among them only 25 was not allowed. So how to remember all these things?
Okay, so yeah, like I really don't. That's true. Because I was not really expecting someone to remember all these 16 values or whatever values on different occasions. I have this idea that maybe that table and like for example the latest question I've discussed regarding this CRS thing. Of course, you cannot remember M SRS value for all the C SRS, so that doesn't really make sense to remember all the
Right,
table. So this
right,
kind
right,
of scenario,
right.
I don't think at all like if even if this kind of question come, you will be given the M SRS information also. But when it comes to this thing you mentioned, na, that the value between 4 and
Periodicity.
640 and 16 different possible values, that was something also I was not expecting someone to remember really. I know that this come in the assignment, and just for that particular question you uh, like what I would really advise, because I cannot tell you not to remember it because it has already appeared in assignment where you are like expected to know that 25, but that doesn't seem very reasonable to me. But
I think two, three rows of the table should be given.
yeah, like in exam that's what I'm expecting. Like we cannot really remember all those things, like some basic things, okay, like mother code rate or all these facts, okay, but from a table 10 12 different values for every other occasion is not a very feasible thing, like, and that's also not the purpose of learning, like remembering all those numbers. And so yeah, like table I am expecting them, they will be given if something of that sort comes, like for example LDPC graph encoding, if such question comes regarding the lifting size and all, the lifting size they will have to be provided because you cannot remember all ZC values, that's impossible. So I just wanted to thank you all, like for attending all the previous sessions, and I also learned a lot of things. I usually make a lot of mistakes, and you are always there to correct me, which helps me also to grow. And you are like quite patient with me, making all these mistakes repeatedly, and but still. So I'm really thankful for you all, and I wish everyone the success for this exam. So, any more questions can take?
And regarding the clarification on the periodicity, CSIRS periodicity, so do we have to remember all those numbers which are mentioned?
I'll do one thing.
That is also
Yeah,
confusing.
I'll ask them once regarding that
Okay.
specifically, and I
Okay.
guess they can answer me that whether these things, this kind
Mhm.
of things, whether, and then I will update it in either I'll update it in the both in the description of the YouTube video and the last page of this PDF also. Whatever, I'll have the answer from them. Okay, is that fine? Uh,
So
I'll.
my
Can you just repeat once? Actually, you are not audible.
I'm saying earlier we were going by the range 4 to 640. If we change that track, then we have to remember all those numbers. That also becomes tricky.
Like that is true. And this only appears in this one example, right? Or there are multiple, so that just I can gather more information so that I can ask them that whether
Okay.
whatever question they are prepared, are their tables need to be remembered or not. So I'll just ask them, and I will whatever they will say, I'll just update this at the end of this PDF, and I will also mention that in the description so that you can have easy access to that. And in the meantime, if you have confusion, you have my ID, like email ID, you can mail there also if there are any more questions. So just to clarify, I should ask them that whether the tables for different kind of questions are need to be remembered or not. Is that the only thing, or I should ask them something else about?
For me, that is the only thing
Okay,
that whether we have to remember all those numbers or not.
okay, okay, sure. I'll ask them and update you about that. Okay, then if there are no any more questions, goodbye as of now. Thank you for attending.
Thank you, sir. Thank you. Thank you for the session. Thank you.
Yeah, thank you so much.
Thank you. Thank you all.
Thank you,
So
sir. Thank you. Thank you.
I'll conclude this session now.